Okay, this is my Module 2 Excel report, and I'm going to go to Formulas. And then go to Show Formulas to show that I did not put in all the numbers that I actually did put in all of the formulas like I was supposed to. Here is my dice. There's that over there. There are all these. Here are my formulas for this one. And here is stuff for the last one. Now, based on all of the data that I collected, for this one, this example I said was empirical because we did an experiment to get all the data shown. And we know this because we know what empirical and theoretical probability mean. And if we were to expand this by extending the survey to more of the population, because this survey in the example said it was 500 women and 500 men, which you put that together, it'd be 1,000 in the area that was chosen. And if you were to expand that to the northern or southern region, or like as wide as just the whole state in general, and it's all up to whoever is doing the survey, the surveyor. Now, number two, the probability of product sums of rolling two dice. Now, based on all my data that you can see, the color coded, the probability of the sum of an even number or multiple of 3, the product of a prime number or 12. If you were to roll two dice, the probability of getting the sum of an even number would be 18 over 36, which, if you reduce it, it reduces it to 1/2. And if you were to roll the same two dice, the probability of getting the sum of a multiple of 3 would be 12 over 36, which would be smaller, reduced to 1/3. Now, if you were to roll two dice, the probability of getting the product of a prime is 6 over 36, would reduce to 1/6. And if you were to roll those two dice again, the probability of getting a product of 12 would be 4 out of 36 reduced to 1/9. Now, expected outcomes. As you can see, there are a lot of numbers, all the different ticket winning amounts, and the outcomes of how much money you would have after those tickets. And after all the calculations that you see in this chart, plus the thing above my explanation, we figure out that the buyer expected outcome is a loss of 193 because they're the one paying for the ticket, so they're going to be the ones that are losing the money more likely than getting the money. The seller has the expected outcome of gaining that $1.93 because they're selling the tickets, and so they're not losing anything. And it's reasonable to believe that the seller is expected to sell 5 million tickets because over the years it's become more popular for people to try to win money because people think, oh, yes, I might not have a chance to get the money, but hey, if I don't try, then I can't get the money. So they go out and get many, many tickets trying to place their bets and actually win some money, which most people end up just getting the money back that they paid, so they don't earn anything. No, because my family used to do it. Now, odds and probability. I said that after reviewing the data, we can see based on the event that we were given in the example problem that they said that there was 9 out of 13, and you can't really reduce that fraction because there's nothing that goes into any of them. But then there's the decimal and the percentage, and then you put that into the chart when the bottom label is probabilities and odds and the size percentages. Now, for people who like more of a visual, I put it down here in the bottom using triangles, and the orange ones are represented by the odds in favor, which if you look in the chart, it says 9 out of 4. So if you count the number of orange triangles on the first diagram, it's 9 over 4. And then if you look at the chart over the against odds, it'd be 4 over 9. And so if you look over here on the example on the right, it's switched, which is a visual representation of what's in this chart above. Now, military personnel. Based on all the parts that were in the question, I made a chart, and as you can see by what the information problem that I got and used, more men are in the military than women. And you can also see this because, and you can also look, if you look, the orange bar represents women and the blue bar represents the total, the gray bar represents men. And if you look at the orange and the gray bar, the orange bar on all these charts, except for the Coast Guard, all the orange bars are lower than the gray, meaning there's less women in that branch than there is men. Now, Coast Guard, you can't see anything, so you can't determine if that is the same for Coast Guard as it is for the Air Force, Marines, Navy, and Army. And lastly, what my classmate told me. Now, this example, we had to use a binomial experiment to figure out if he or she really did get 8 out of 10 questions right just by guessing. Not a lot of people, without like doing a binomial experiment, would believe that, because not are that lucky to get like maybe like it's normal to get like a couple questions right by guessing, but it seems unjustifiable that you could get 8 out of 10 by guessing, because it's just not common. So if you put the numbers into the experiment, binomial experiment, then you get the percentage of 0.03%. And the way you get this answer is you put in X, which would be the 8 questions that they got right, and you put N in, which would be 10, which would be the 10 questions total, and then it said that it'd be 1/4 of the questions they got right, and so that's the probability, and so you plug all that in, which gives you your 0.03864%. And so if they were to tell me this based on the binomial experiment that I conducted, I would have a hard time believing them, but it could be possible. It just isn't very likely. And that's my Module report.